Another video. Today we're going to be going over the limit definition theorem, essentially derivatives, right? This is the introduction to derivatives and that instantaneous rate of change idea. Now, before we get into that, I kind of wanted to explain what this essentially is. So far, up until calculus, you have been told that in order to find the rate of change, you need 2 points. It's the rise over the run, or the change in y over the change in x. In calculus, however, we challenge that idea by trying to find the slope at one particular point. The way that we do that is by using limits. So if I kind of draw a graph here, again, I'm going to go really fast because we have a lot of questions today. But essentially, if this is x and this is y, I can name another point along this line right here, x plus h, right? In other words, the x value plus some unknown additional portion, which also makes this y plus h. Now, using limits is as it's approaching a point, right? So what if I take the limit as h is approaching 0? Well, wouldn't that essentially just bring us back to this particular point as h is essentially just getting moved to 0? In other words, finding the slope at a particular point. So if you look right here, it's the distance in the y values over the distance in the x values. Well, there is no distance in the x values because the x's are converging on each other, and h is eventually approaching 0. That is what this formula is basically saying. Now, in order to use it into an equation, what we're going to do is we're going to kind of understand the idea of a function. What a function is essentially you input things and an output comes out, right? That is the idea. So in this case, what this says is f of a plus h. That means I'm inputting a plus h everywhere I see x, and that should output me my new equation. So in other words, -4 times, again, I'm going to expand this out. This is a binomial squared, so a squared plus 2ab plus b squared plus 2a plus 2h plus 5, and then all this stuff here as well, so minus f of a squared plus 2a. Actually, let me just distribute the negative here, so this is actually going to be minus 2a minus 5 all over h. Okay. Now, let me see here. What I'm going to do now is I'm going to start combining like terms. So I'm going to distribute. Well, actually, let me distribute here first. So actually, these are going to cancel out right here. That's nice. Okay. What else is going to cancel out here? Okay, the 5 and the -5 look like they're going to cancel out. The 2a and the -2a are going to cancel out. Okay, so that just leaves us with -8ah minus 4h squared plus 2h over h. Cool. Now notice how all these have an h term, so I could take that out. I'm going to factor it out of everything, reduce essentially, and that's going to give me this. Now remember, it's as h is approaching 0, right? The limit as h is approaching 0. So this term basically erases itself. Okay, and then the last thing here is as x is approaching -1, so I'm going to replace a with -1, which is going to give me 8. And 8 plus 2 equals 10. Okay, so that's basically how you do this, right? I'm literally just replacing everywhere I see an x with an a plus h form, expanding out, simplifying everything, reducing everything out. Once I get to the very end, making sure that my h values return to 0, right? Because it says h is approaching 0, and then plugging in my value to get my final answer of 10 here. Okay, so let f of x equal 40 minus x. And then we're going to have to make a line as well. Okay, so the idea is the exact same thing here, right? I'm going to take the square root of 40 minus, in this case here, it's going to be 4 plus h minus the square root of 40 minus 4 all over h. Okay, so now I'm going to combine like terms. All right, 36 plus h minus 6 over h. Now I can't, even though I want to so badly here, take the square root of 36. I'm actually not able to do that here because it's connected to the plus h. If this was 36h, then I could. But the fact that it's plus means I'm not able to do it here. But my next step would theoretically be able to zero out the h's, but notice my h is in the denominator. So I'm not able to do it here because that would make this not real because you're not allowed to have a denominator of 0. So what I'm going to do instead is I'm going to multiply by the reciprocal on the top and bottom, right? My intelligent form of 1. So 36 plus h, now plus 6. And I'm going to do this on the top, and I'm going to do this on the bottom as well. And what that's going to do is it's going to allow me to eventually plug in h as 0 without having to deal with the fact that the denominator would end up equaling 0. Now, in order to do this, this looks scary, but it's actually quite simple. This is a difference of squares, so we just square the first term and the second term. Squaring the first term, well, if you square a square root, just whatever's inside just comes out. So 36 plus h. And it's a squared minus b squared, so this is going to be minus 36 over, I don't know what that is, so I don't care enough. I'm just going to do maybe 6h plus h times 36 plus h. Actually, you know what? In this case here, I think it might be better just to leave it. Just like this. Keep the h by itself, just in case we get rid of it here pretty soon. Okay, so 36 plus h minus 36, these are going to cancel out. Oh, it's minus. Well, I completely messed that up. Minus there, so this is going to end up being 36 minus h. So this is actually going to end up being negative h here. Again, I just forgot to distribute negative 4, and then this is going to be minus h here. Okay, so now I have this thing. Now notice the h and the negative h here are going to cancel out, leaving me with just negative 1 over the square root of 36 plus h, which I'm just going to plug in 0 now, right? The reason why I'm going to plug in 0 now is because now that I have eliminated the h out here, if I just have h approach 0 here, it's not going to make the denominator 0. It's actually going to be 6 plus 6, because 36 plus 0 is 36, square root of 36 is 6, which gives me negative 1/12. Now again, what this solves for is the instantaneous rate of change, in other words, the slope. So now what I'm going to do here is I'm going to use point slope form. So y minus 6 is equal to negative 1/12 times x minus 4. So this is going to end up equaling y is equal to negative 1/12 x. And let's see here. Negative 1/12 times negative 4 is 1/3. 1/3 plus 6. Let's think here. That'd be what? 18/3 plus 1/3. So that's going to end up equaling 19/3. Making this right here the final answer for number 2. So what I'm going to do for this one here is I'm going to show you another way to solve these. Now, again, the process is still the same, right? So if you want to use the limit definition theorem for all these, by all means do it. But in terms of speeding it up, there's actually a quicker way, which is actually to take the derivative. Essentially, you take the exponent, move it out in front, and then you subtract 1 from the exponent. So in this case here, I'm going to move the 3 out in front. 3 times 3 is 9. And then what I'm going to do is I'm going to subtract 1 from the exponent. 3 minus 1 is 2. So in other words, the derivative of this thing is 9x squared. Now what does this do? This is essentially a key to the slope at any single point on this graph. That's essentially what it is. That's what a derivative is. It's not the actual slope. It's a key to find the slope at any single point. And the way that you use it is, well, I'm going to plug in -1. And I'm going to plug it into this equation. -1 squared is 1. And then I'm going to get 9. So in other words, the slope here is equal to 9. So all that stuff I just did there, I just did it just by doing this. Slope is 9. So now I'm going to do the same thing with y equals mx plus b. So now I have y plus 3 is equal to 9x times x plus 1. And that's going to give me y is equal to 9x. Again, I'm just distributing. And then I'm going to subtract 3 here, which is going to give me plus 6. Again, I'm going to do the same thing. I'm going to move this out in front, subtract 1. That's going to give me 10x. And then from here, I'm going to plug in 2. So my slope here is 20. And that's it. Simple as that, right? I just did this whole question in 2 seconds. Again, if you wanted to use the limit definition theorem, plug in a plus h everywhere you see an x. So just right there, minus this. Essentially, it's going to kind of mimic this, reduce out, and then you'll get the answer. It'll be the exact same thing as this. Now here, I wanted to do this one as the limit definition because this one looks a little bit more complicated. So we'll work through this one together here. So again, a plus h everywhere I see x, so 1 over. Now from here, I'm going to have to be able to combine like terms here. So let's see, what can I do here? What I'm going to do is I'm going to do something called the Dr. Seuss method. This is what I learned when I was younger. And essentially it's if this times this, or this times this minus this times this over this times this equals this. Essentially what it means is you're going to cross multiply starting from the bottom right to the top left, then minus the bottom left to the top right over these two multiplied by each other. So that's going to equal. So let's see what we can do here. First thing I'm going to do is I'm going to simplify the top. So it looks like a minus a. This is essentially going to cancel out here. So there. And then I got -2 minus -2. That's the same thing as -2 plus 2. So that's going to cancel out. Okay, leaving me with minus h. Okay. Now here, what I have is essentially a plus h. Now, in this case, it's the same thing as multiplying. Anytime you're dividing a complex fraction, what I would do is I'd multiply by just the fraction. So this is the same thing as just multiplying by 1 over h. Notice how these are going to cancel out, giving me essentially -1 over all of this stuff. And then from here, what I'm going to do is I'm honestly just going to plug in 0 for h here, just so I don't have to deal with it. So that's going to give me a minus 2. So if I plug in -2, let's see, -2 minus 2 is -4. -2 minus -4, so this is actually going to be 1 over 16. Let's see here, -1, -1. That's going to be +1, so this is just going to be -1 here. 4 minus 2 is 2. 2 and 2, -1/4. And then this one here, I'm going to get what? 6 minus 2 is 4. 6 minus 2 is 4, so -1/16. So what I'm going to do here is I'm going to rewrite this as an exponent. Anytime something's in the denominator, we can rewrite it as that exponent over with -1. So then I'm going to use the derivative, so it's going to be -1 times x minus 1. -1 minus 1 is -2. So now I'm going to rewrite this as just -1 over x squared. Again, the negative puts stuff in the denominator, so I just put it in the denominator right here. If it's in the denominator, you want to take it out, you make it negative. That's kind of the idea. And then I'm going to plug in negative 4. Negative 4 squared is 16, so this is going to be negative 1/16. And that's the final answer there. And that's basically it for today. So if you guys have any questions, feel free to drop it into the website there. Or if you want tutoring or anything like that, again, you'll see it on the website in the next clip. If you guys ever want more help with your math, feel free to join mindleaptutor.com. At this page, we do have one-on-one tutoring sessions. You can click here and view the plans. If you just want a video taken for a question that you have, feel free to go to the math resources page, video archive, scroll down to the bottom here, click submit a question, and I'll have those questions for you as soon as the end of the day. But until then, I'll see you guys on the next video. Take care. Peace out.